Guys, we'll just wait 2-3 minutes. Let everyone join. Then we'll just start off with today's session. Fine? Am I audible?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes,
Okay,
ma'am.
fine.
Yes, ma'am.
Fine, great. We'll just wait 2-3 minutes. Fine.
Ma'am, till then I can just show you the changes you just told me to update in my project.
Yeah, can you come again? I just missed out.
Um, you just told me to update my project, just adding the XGBoost model.
Yeah, yeah, right.
So I had done
Did
the
it
changes here.
performed well?
Yes, ma'am. On Monday only I have performed it.
No, no, I asked you, did the model performed well? What is the accuracy? That's what I am asking.
Yes, ma'am. Actually, the first day I tried now on Monday, so it was taking too much longer time for all the three
Right,
models
right,
to run. So I just
right,
combined all
definitely.
the three model into one cell and then it ran it.
Okay, fine. So what accuracy you received? You want to show, then you can just share your screen.
Yeah, ma'am. I am just ready with it.
Okay, fine. Then share the screen.
Yeah, ma'am. Yeah, ma'am. Is it visible?
Yeah, visible.
As been seen, all the everything is just like the old one. Nothing changes are done in other cells.
Yeah, yeah,
Just
that's fine.
here, logistic regression, elastic net, and XGBoost. I have just combined all the three models into one cell, and so it
Mm-hmm.
is the output. And here I have mentioned the training time because while doing this, it's
Yeah,
separate in itself, so it was taking all too much time. Means it was taking
right,
10
right,
minutes, 15 minutes, and it was getting disconnected. So I
right, right.
just
That actually
done it
happens.
into the one cell. So logistic
Mm-hmm.
regression got 0.91 and elastic got 0.89 and the XGBoost got 0.96.
Okay, then it performed better, right?
Yes, ma'am. And just a slight change I had done in the final step, right? I have
Mhm.
just done the this models comparison into the graph.
Yeah, that is fine. That is a good one that
Yes,
you did.
ma'am.
So it
Yes,
was
ma'am.
easily understandable that XGBoost worked better, right?
Yes, ma'am. Yes.
So that's so you have already seen like XGBoost worked better for this, and I
Yes,
hope
ma'am.
like so that's fine. So it's good that it worked better, and you got around 92 or some what percentage? What is the accuracy?
It is
98 around.
0.91,
Okay.
0.89 and 0.96.
So it is far better than like it has like performed like very better than a logistic because in logistic it was 91, it is 96. So
Yes.
5% better. So that's really nice.
Okay, ma'am.
Yeah. So now it's fine. It's good.
Yeah, can I stop sharing?
Yeah, yeah, definitely.
Yeah, thank you, ma'am.
Yeah, so for this kind of models or this kind of data set, try to use this XGBoost or GBM. GBM just take longer time than XGBoost also. Like XGBoost does takes time, but GBM like it will take more time, I guess. But this models the like have a tendency of giving accuracy better.
Okay, ma'am.
Yeah. So we can just start off with today's session. So just a minute. Okay. So today we will just go ahead with like today's basically this week agenda that we can figure out the very first thing that we need to check, that is we will be learning with unsupervised learning. So what is unsupervised learning? We will be considering that. We'll learn in details about unsupervised learning and eventually move ahead with the other details. So let me just share my screen. Screen is visible.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, okay, great. So what we'll do, we'll go ahead and learn about this unsupervised learning, then different types of machine like unsupervised machine learning model and how it actually works. We'll check into that, and eventually we'll see how what are the evaluation metrics, how we can think it of, and in what format we can go ahead and work with unsupervised learning. Last week we have worked with supervised learning. We have seen in details how supervised learning works and in what format they work. So this week we'll just go ahead with unsupervised. So anyone wants to put in their view about unsupervised learning? Any points? Anyone? No one?
Yes,
Ma'am, the
ma'am.
input here is not labeled.
Ma'am, we
Yeah,
handle
ma'am.
Yeah.
unstructured
Unlabeled
data.
data.
Yes,
Ma'am, yes,
yes.
ma'am, I
One by
can.
one, please tell. Tell.
The
Yeah,
input here is
unsupervised
not
learning means the data which are not labeled. That means the data which are we are giving, it's not labeled one.
Okay, okay, fine. So ideally, that is the correct option, correct thing. Like we are getting the in case of supervised, what we are actually doing. Just let me just open that file as well so that it will become easier. Yeah. So here what we are getting, we are giving y, x and y in the training stage itself. We are getting in case of supervised, I'm saying, we are getting this x value and we are getting this y value. So in case of x, we are getting the values, whatever based on the value, what would be the predicted value or what would be the y value that we are also like what would be the value like the training in case of training, what would be the y value or the label value that also we are giving to the model in case of training purpose, right? So now in case of unsupervised, there is a catch. What we are doing in case of unsupervised, we are giving the, of course we are giving the data to the model. We are trying and giving the data to the model, but that data is not labeled. The data like the output value that the value like the data will have, that is not given to the model in the training stage. Okay, so supervised ml, like ml model, what it is, it gives, we gives the computer a lot of unlabeled data, the data that doesn't have any answer, or we can think it of like any question that is having no answer. Okay, so what actually is the task of unsupervised? So let me just write the task. Unsupervised machine learning. So what is the task? So first, what it needs to find, it needs to find the pattern. So what it needs to find the pattern that is there inside the data, like inside the basic data that is there and that is needed to be taken into consideration. Like the what data model is having. So in that specific data, what is the hidden pattern or what is the structure that needs to be finded out. So first it finds the pattern, maybe the groups, or it can find the structures. Fine. So what actually is the task of machine learning, unsupervised machine learning? The machine learning model, unsupervised machine learning model is given with data that is unlabeled. That doesn't have the answer to the question, right? So based on that data, the model tries to find the pattern, groups, or structures that are hidden inside the data. Model tries to find it out. Fine. So let me just give you an example. Suppose all of you are done with the schooling part, you are in the college. Suppose after the on the last day of college, we do have a tendency of going out with all of the friends, because the all of the friends, like when next we'll meet all of the friends. So there is a tendency of going out and doing a some of the like party kind of stuff, where that is the normal thing that generally school students do, right? So imagine you enter a party and you don't know anyone. Like suppose just for an example, you can think it of like that. So you imagine that you enter a party and you don't know anyone. So what you will do? You will start grouping with people. Like so, people who are there in the party first, right? You will just observe the people who are there in the party first, right? And will try to group with people. Suppose there might be people who is very extrovert, so they are just laughing out loudly, they have come with friends, so they will be just like gossiping inside on a certain table, ordering stuff, ordering foods and stuff, and they are just giggling. Okay, this is one kind of people. So there you might see some people who are actually just dancing, or they are just like separately they are hitting the floor, they are dancing, this kind of people. So they are just going some, maybe somewhat with one or two people, as some two people friends group has came up. Or there might be some people who are introvert, who are just sitting in a corner with the foods, enjoying the vibe, enjoying the food, like that. So you can see there are different groups in a single party, right? So what you are doing, you are trying to like just name this groups that you have got into a specific name, so that these are the extrovert people group, these are the introvert people group, these are the dancing people group, like this. And with whom, like with which group you try and tend to get the vibes similar, you try to go into that group, right? So this actually is what supervised learning do. So when you enter to that very party, you don't know no one, right? Based on your observation, your identification, you have grouped people into three different groups. So same thing the supervised machine learning does. So what it does, it analyze what first the data has been given to the model. So the three steps that model performs, that is interpretation, then algorithm, then processing. So what happened in the interpretation part? So model acquired with the unknown output. Like the model has been given with the unknown data. So there is no training stage, no training where the data, like data has been known to the like there is no label, or there has been no training session where data came across to the similar kind of data, and this is the output phase or the testing phase. It is not like that. At the same go, the model has came across with this data. Okay, so what it will do, it will first observe, it will first interpret how the data is. It try to get into what is the pattern, try to analyze the data. Fine. Next, after doing this, what is the algorithm it will do? Suppose in case of supervised, we know the data comes into the cluster format, or it comes into like it find out the inner trends. Maybe we might find and try to find out the inner trends, or we can try to find out the patterns, or we want to get into the structure format. So what algorithm I want to put in that very data, that has been selected. Fine. And then the processing part. In processing, what it does, in case of processing, it try and understand what like based on the algorithm, how my model performed, and try to give an output. Fine. Understood what exactly is supervised learning and how it performs?
Yes, ma'am.
Yeah, well,
Yes, ma'am.
Anyone have any question till now?
No, ma'am.
Great. So you can see this picture, right? So it's been given with input data. So here animals are been given, different kind of animals has been given. You can, someone's mic is on, it is echoing. My voice is echoing only. Can you just switch off your mic? So you can see this data, right? Here you have been given with an input data where you have been given with input raw data of different animals. So it has been given elephant, then it has given camel, then it has given cow. So the model has never acquired with this kind of animals data, or it is very new to the model. So it is the raw unknown data that has been given to the model. Okay, in the training section of the model only. Fine. So now what it does, it interprets like interpretation stage. It observes the data. What are the basic criteria that the each of the like each of the animal is having? What exactly is the like criteria based difference? Suppose this input data has been given in pictorial format only, right? So interpretation, it observes, sees how it is. Then in algorithm part, so what would be the best algorithm to suit and go ahead with this and for working with this kind of data. So it sees and understands the different facial, like the figure-based structure of each of the animal. So it sees that what are the different structures that each of the animal is having, and based on that, what it tries to separate each of the animal into different sections, and sort of best algorithm might be clustering or grouping, you can think of. As of now, forget clustering, think it of as grouping. Because there is three different animals. So it wants to group it down. So after it has grouped it down in the processing section, what it does, it tries to understand based on the grouping, like what algorithm it has put in and did it work well. So in the processing, it has processed based on the algorithm has been processed on this raw data. Okay. And we have got the output as three different class of animal, that is elephant, that is camel, and that is cow. Okay, clear, understood?
Yeah,
Yes,
okay, ma'am.
ma'am.
Ma'am, in semi-supervised and unsupervised learning,
Mm-hmm.
ma'am, in semi-supervised and unsupervised learning, we will follow this same step, ma'am.
I didn't get you. Your voice got broke. Can you come again?
Yeah, in semi-supervised and unsupervised learning, ma'am,
Mm-hmm.
we will follow the same steps as we followed for supervised and unsupervised learning, ma'am.
Uh,
Or it may vary, ma'am.
that might differ. What actually semi-supervised is, yeah, what actually semi-supervised means. So you have learned about supervised. So the word semi means half, or you can think of partially. And unsupervised, where we train the model using unlabeled data. So semi-supervised learning is that when we train the model using small amount of labeled data, and there is other part where we get the large amount of data is unlabeled data, right? So what you
Yes,
see,
ma'am.
some of the data we are getting, like small amount of data we are getting in the training of the model itself. Some of the data that we are getting, that is labeled, and the other part of the data that we are getting, that is unlabeled. So in case of unsupervised, you see all of the data that you are getting, that is totally unlabeled. So the model need to work from scratch, right? So in semi-supervised, it is like some of the data that is labeled, and the other part, like the major amount, is unlabeled. So based on that, it might came to a scenario where in the real life, it what it does, it get the raw data, and based on the labeling that it does, it try to labels it down if the data are similar. Okay, suppose an elephant and camel and a cow. This data has already been given to the model and with the proper output, right? So this part is already clear to the model that if I get across this data, now I can label it to this. So some part the model already knows. Now in the next section, when we are giving the model the unlabeled data, some of the data will be of course there in the unlabeled where it will get elephant, camel and cow, right? So model already knows it, so it will easily go ahead and turn it on, and based on that will label that. And for the part that is totally unlabeled, it will try to analyze, and that for that part it will try and go ahead with any of this like this kind of unsupervised part. So clear?
Yes, ma'am.
Yes, ma'am.
Yeah. So what actually we does in case of semi-supervised, we take a small labeled of data. Suppose 100 data we have taken into consideration, that is labeled. Large amount we are taking as unlabeled. Suppose the unlabeled amount as for small label, or the label data that we have taken, that is 100. The unlabeled data may be 1,000 or maybe 10,000. Okay, then we train the initial model, whatever be the initial model that has been trained. So no, the model is not very accurate in case of the data that will be getting like the unlabeled part, but for the labeled part it will, as it already learned, it we will be getting the accuracy more, right? After training will predict the labels, what I told, it will predict the labels, and on the unlabeled data it will try to give prediction based on the data, based on the understanding that it gets from the labeled data. Then it what it does, it does give a combination that we can get a pseudo labeled, like this like pseudo based labeling it might give. And then it tries to like, then the after it gets trained and evaluated, if it is working fine based on that very data, that is well and good. After hyperparameter tuning, if it is going good, that is also fine. If not, then it has to go with the data to make it again understand with the data. Fine? Clear?
Yes, ma'am.
Yes, ma'am.
So who have actually asked the question, for who, for them, like for him actually, is it clear? Who actually asked the
Yes,
question?
ma'am. Yes, ma'am. Yes, ma'am.
Okay, okay, fine.
We can
Fine.
also
So
able to create an algorithm, ma'am. Ma'am,
sorry.
we can also create the algorithms, ma'am.
Yeah, yeah, in supervised, you see, right? We have decision tree. That is the given algorithm. Then what, like initially we have only decision tree. Then just GBM, XGBoost, only we people have created and then taken into this libraries. We got this libraries, right? So what actually we are doing in GBM or more like label trees, or where we are taking into consideration one or more tree at the same time, there we are combining the initial algorithm only, right, to make our model learn better, right? So this is what actually we are doing. It's not like, if like it haven't came into consideration that anyone is building the algorithm from scratch. So people, what nowadays people do, people try and do ensemble learning. What they are actually doing, they are trying and combining one or two models together and make it a new model, or make it a new algorithm based on that, and see if that models work well for that data or not, or any kind of other data. So nowadays we are working with the ensemble part, where we are combining two different types of algorithms together. Fine.
Yeah, yes, ma'am.
Okay. So next, what we can go ahead with, we can try and understand about unstructured data. So what actually we are doing? So what unstructured data, the data that is not structured, like we are just having the structure, just having the data on, that is not well maintained, or we are not getting the range, or we are not going with the scaling part. This is the reason, in case of unstructured data, we need to do the scaling. Okay, as a pre-processing part, we do try and get and do the scaling operation. In case of K-means, I guess some of you have done K-means problem in this week's project. So I guess those have included the scaling operation in the data, so that the data is more scaled and like it is widely spreaded and well scaled, so that that can be worked in a format that when that data will be given to the model, that model can easily learn and create the algorithm based on it and work accordingly, right? And unlabeled data, like the data has no given output, or the answer to any of the questions or has not been given according to the data. The data has no label, it is totally vacant, and based on that, the data has been given to the model. Okay. So next, what are the key goals of supervised learning that we will be learning? So basically, the key goals or key algorithms that basically supervised learning uses, that sorry, unsupervised. I'm really sorry. It is unsupervised. Unsupervised learning uses, that is clustering. What is clustering? Clustering is like grouping similar data points together. As I given you the example of that party, right? So what, based on the observation, what you people are doing, you are grouping each of the groups of the people in different segments. Based on what? Based on the criteria, based on the features that the people are showing, right? So key goals, or you can think it of as the algorithms that supervised learning is following. So let me just write. So algorithm basically that it follows is clustering. Next, what it does, it is dimensionality reduction. You can think of PCA. Next, we can think of like pattern or anomaly detection. This all the stuff that actually unsupervised learning do. Okay. So these are the basic parts that we can take into consideration. So what clustering is, it is grouping. We will be going ahead with each of the part in more details and understanding how we can think it of. So in case of clustering, is just like grouping. Then dimensionality reduction, it's like simplifying data. You can think of simplifying the data and reducing the dimension. So what reducing the dimension means, like you, it is like compressing. Suppose there are 100 features, okay, and you want to compress this 100 features into suppose 20 or 30 features, or maybe in certain case we do it to 2 3 features also for any kind of visualization. So what we are doing in dimensionality, we are simplifying data while we try and keep the major or the important information intact. Okay, so we are doing just compressing. And next, what we are doing in case of pattern or anomaly detection, we are finding unusual data points. Anomaly, what anomaly means, like you can think of like it is the outlier, right? So what it actually does, we are trying to find unusual data points that are there. So you can think of about fraud detection in case of bank transaction. There, what happens? We try to get the anomaly where, in which statement, in which bank statement, or in which bank transaction we get this like fraud happened actually. So we try and analyze all of the data so that we can get that unusual pattern or unusual data point where fraud has been created. Right? Understood? Like vividly, you understood. Like briefly, what exactly is clustering, dimensionality reduction, pattern and anomaly detection.
Yes, ma'am.
Right? Okay,
Yes,
great.
ma'am.
So okay, great. So next, what we'll do, we'll just move ahead with the types of unsupervised. So what exactly is unsupervised that we'll take into consideration? take into consideration. So you can see here we have k-means clustering, hierarchical clustering, DB scan, that is density-based spatial clustering for applications with noise. Next is mean shift clustering for association rule, like has been divided into forms where we have taken into consideration this association rule learning model where we are taking into consideration a priori algorithm, eclat algorithm that we will be taking, FP growth algorithm we will be taking into consideration, efficient tree based algorithm that we will be taking into consideration, anomaly that is basically isolation of forests, like what we are doing in case of isolation part that we will be taking into taking into consideration. Next, in case of dimensionality reduction, we'll take PCA, that is principal component analysis, then linear discriminant analysis, that is the lower version. Like PCA is for dimensionality reduction that we generally use. There are certain cases where we use this LDA also based on the problem that we are taking into consideration. We will be taking into look about non-negative matrix factorization, then locally linear embedding, isomap, all of this will take into consideration. So in a simple way, let's just take an example and based on that, understand what unsupervised learning, like machine learning model actually do. Okay. Just excuse me a moment, please. Okay. So let's just move ahead. So you people able to hear me, right?
Yes, ma'am.
Yes, ma'am.
Okay, fine. Okay, actually, I am facing some network issue. Like, so in between, if you unable to hear me or anything happens, please try and let me know. Okay. Okay. So what will Okay, so we'll see how unsupervised machine learning works. Okay, suppose we have three groups, or sorry, we have three columns we can take into consideration. We can take person, next we can take height, next we can take weight. Okay, so we'll fill with some of the data. We can take A as the name of the person, height might be 150, and the weight we can take it as 45. Similarly, another person B that has came it up now 152. Okay. Next we have come across 47. Now C, let's just take it a bit higher, 180 maybe, and 80. Now D, another people for the person maybe 175, and the weight is 78. Fine. So in the training phase, this data is been given. This data is been given to the model. Okay. So you have created the model. This data has been fitted to the model. So what model will do? Model will try and analyze, view this data. So what it see for person A, the height is 150, The weight is 45. For B, the data is height is 150 and weight is 47. For C, the height is 180 and the weight is 80. For D, the data is 175 and the weight is 78. So what it try and do? First for A, it will see. So this is the data actually having. So from one data, no one can understand anything. It is not possible for person also. So the model will also not understand. So it will try and compare this A with B. Okay. First, it will try and compare this A with B. Okay. So after comparing it up, it is saying B, that is another person for which that is the height is 150 and for B the height is 152. So when it is comparing between like the height, basically it is comparing the height of A and B. See, it is seeing 150 for A and 152 for B. So it is getting the difference, that is 2 centimeters, suppose. 2 centimeter is the difference. And when it is checking for weight, so what it is checking, there is an increase of weight. So that is 2 kg it has increased for person B. Right? Understood what I told?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay.
ma'am.
Yes, ma'am.
Okay, fine. Now what it does? Okay, okay, got it. So this part is done. A is comparing with B. Now what A is saying? A1 for this part is done. For this part is done. Now it tries to compare with A with C, B with C. Okay. So for A with C when it is comparing. So similarly, A is comparing with C for height. So what it is getting the difference? That is 30 centimeter difference. And what it is seeing for weight, so it is around 45. So it is around 35 kgs is different. So what it is saying, when the height is like, after, it's not just by seeing C, and it will also analyze D, then it will be seeing that for height who is which is shorter, the weight is less as compared to the person whose height is taller, the weight is also is more, right? Understood? Near about comparing all of this, it's not like only A is comparing with B, then A is comparing with C, and A is comparing with D. No, not like that. It is doing that. Then also in the similar form, B is getting compared with B is getting compared with D. In the similar format, C is getting compared with D, right? So all of the patterns has been seen, and based on that, everything has been done. The comparison based on the height and even on the age. So after all of this comparison, what the model get into access? So it will tell and it will create two clusters, or you can see groups. So in based on two groups, what it will see and what it will tell. So there are two clusters where A and sorry A and B is there. Okay, so that is cluster one. And what labeling? If it has to give any labeling, then it will give the labeling like they are short and there is weight is light.
Ma'am, can you zoom in the screen, ma'am?
Okay, you can't see it. Just a minute. Fine.
Yes,
Is,
ma'am.
or should I zoom more? Okay, fine. So for two clusters, it is getting two clusters, that is two groups, A and B. We are considering as cluster one. Then we are saying that as the person, it is short and weight is light, right? Next, what we are then what is the another group, that is C and D, that is another group, that is cluster. Just a moment. Cluster is 2. What is, if it is has to label, what it will label tall, plus it will, like the person is weight wise, the person is heavy. So clear, this is how we are creating the clusters. Guys, understood?
Yes, ma'am.
Yes, ma'am.
Yes,
So
ma'am.
properly I am audible to you? Like, are you facing any breaking of my voice or anything?
No, ma'am. No, ma'am.
No, ma'am.
No, ma'am. No, it is clear.
Okay, okay, great, great. So we'll go ahead with some of the parts where we are trying and use like using clustering. So in a simple way, you can think of getting like finding groups where we can find groups in case of customer segmentation. We can think of we can find groups. What we can do in case of going ahead with clusters, we can discover patterns like see here we are discovering with the patterns like what is like what are the pattern we are getting. So A and B, these are the person who is actually short in height and have like also light in weight, right? Similarly, this is the pattern that has been that we actually got. So this is the pattern that we actually received up here in case of this cluster 1 for A and B. For cluster 2, that is C and D, tall and heavy. This is the pattern that the model has discovered. Okay. So next, what we can do with in case of clustering, we can detect frauds. So you might think how we can detect frauds, right? So suppose we are working with some of the data, suppose fraud and non-fraud data we are getting. Okay, just a minute. Right. So we are getting, this is the division that actually we are doing. That actually we are doing. Right. So what exactly it is actually not from the very beginning stage. When we are giving the data to the model, it is not segregated in a form that is data. This is the fraud data. This is the not fraud data. Right. So suppose the data is like 1, 2, 3, 4, 5, sorry, 5, 6, 7, 7, like this. So suppose these are the 7 are the data, and suppose in order it is going. Suppose let it just do it in that format, and we are getting 1,000. Okay, okay. So suppose this data is given to the model. So based on this, when the model is checking with this data, what model is trying and understanding? So there is a certain difference between 1 minus, like there is a difference. So when it is checking, it is comparing. So 2 minus 1, what we are getting? 1. So again, 3 minus 2, what we are getting? 1. So again, 4 minus 3, what we are getting? We are getting 1. Right?
Yes, ma'am.
Understood what is the pattern it is following. So when it we are going into this till 6 minus 7, we are getting the difference as 1. But when we are doing it like 7 minus next point, sorry, anyone is saying anything? Guys,
No,
anyone
ma'am.
saying anything? Fine. So 1000 minus the 7 when we are doing, we are getting 993. So that is not matching with this value, and this value is way more different than the values that we are taking into consideration. Right. So this actually forming from 1 to 7, actually 1 to 7, we are getting the data that we are actually getting some of the pattern we are getting. But in case of for 1000, in this kind of data, in this data, there is no pattern. The pattern is getting breaked. Pattern is breaking, right? So that's why this data point, that is 1000, is checked as fraud. Like, I am just giving you a simple example to understand, but in case of data, what how data will be like that, in that format we can check, right? So understood how we are checking for fraud, not fraud, how we are getting into format.
Wait for smart.
Yes, ma'am.
Yes, ma'am.
Yes,
Okay,
done.
fine. Anyone's mic is on or what? Okay, fine, let's just move ahead. Okay, so next, what are like the types of clustering? There are types of clustering also. So we have centroid based, that is k-means. Let me just write it for you. Clustering types. So number one, that is centroid based. That is, we can think of k-means. Next, number two, we can think of hierarchical, that is agglomerative or divisive. Hierarchical actually. Hierarchical, that is agglomerative or divisive. Divisive. Next is density based, that is DB scan. Next is model based, that is Gaussian mixture model, GMM. Next, there are others also that we can't define it in any of this, which form it is. We have mean shift, we have spectral clustering. These are all special, special clusters you can think of, where it has a special strength. Each of it has based on a special strength. We can think of mean shift and spectral. Okay. So similarly, in this step, these are actually what are the clustering in case of centroid, that is k-means. So you do know in that case we need to get the Euclidean distance, like the distance measures, like how actually we go and see the similarity. So here, what we are doing, we are getting the similarity. But in certain cases, what it actually, here we are getting the similarity. So based on that, in case of uh, ordinary straight line, we are trying to get into the distance between the points. Suppose we can think of, just a minute. Yes. Suppose these are the points. Okay, so these are the points. And what it is, suppose this is the centroid. So what we are trying to get into, we are trying to get the distance. What is the distance of this point? What is the distance of this point from the centroid? So how we are doing it? We are trying and doing it by straight line. Okay. So again, what we are trying to do, we are trying to get it by the form of a straight line. Similarly, this point we are trying and getting it in the form of straight line. So basically, what we are doing, what we are doing, yes. So what we are doing, we are trying to get and identify or measure the distance. Okay, so this is how we are actually creating. So for this part, what for measuring the distance, we are doing Euclidean distance. So what is it? It is root over x minus like we like. Let me just give you an example. We'll be doing that. Okay, just okay. So next we'll understand about Euclidean distance because we need to find out the distance of the points, right? So, suppose for an example, what we are taking 2 points. Okay, suppose we are taking 1 comma 2, and another point we are taking it as suppose 4 comma 6. Okay, just a minute, 4 comma 6. So these are the 2 points we are taking. So now we need to find the distance between the points. So this is the x. This is the y. This one, 4 is the x, 6 one is the y. So now we need to find the x difference. Okay. So how we are taking it? Now we will be doing 4 minus 1, x2 minus x1. That is the formula. So we are doing it. We are getting what we are getting. We are getting 3. Right? So similarly, we'll be doing y difference. So what will be there? That is y2 minus 1 y1, that is 6 minus 2, that is 4. Now what we need to do? We need to square it down. So we'll be squaring it up. So square of 3, it is 9. And eventually we'll do square of 4. Just a minute. 16. So now what we need to do? We need to add it down. That is 9. Let me just write. Sum would be 9 plus, sorry, 9 plus 4 that is 25. And we need to do the square root. Square root of 25 we need to do. That what we'll be getting? 5. So what actually is the distance? Euclidean distance that is 5. Understood?
Yes, ma'am.
Guys, how we are calculating this Euclidean distance? Understood? Okay,
Yes,
fine.
Yes,
ma'am.
So
ma'am.
there is not a single like it's not okay. So it's not like we can just calculate the distance between the points using Euclidean distance. There are other distances also that we can take into consideration. There is cosine difference. What cosine difference does? It finds the angles between the vectors. If we are considering
Yes,
any of the
ma'am.
vectors up here, if we are considering any of the vectors up here, so cosine similarity, it finds the angle between the vectors. So the next is cosine similarity. And another way to find the distance, that is Manhattan distance. Okay, so it's do like here we have taken the difference, then gone ahead and done the evaluation, right? So in case of Manhattan distance, what it does, here we actually, after dividing like difference, we have taken the square of it and then added. In case of Manhattan, we take the absolute value. So what it is, let me just give you like Manhattan. Sorry, Manhattan distance. What actually here we do? We after we have done x2 minus x1, we get a value like 3. Similarly, y difference, y2 minus y1, we get a value. So here, in case of Manhattan, we have squared it and then added it. Sorry, in case of Euclidean, we have squared it, then added it. But in case of Manhattan, we'll take what? The absolute value, like absolute value as 3 plus 4. So since they are positive values only, we will be like, even it is any other value, we will be getting the positive value from the mod only. So it is 7. So the Manhattan distance for these 2 points that we have taken as example, it is 7. So understood what is Euclidean distance, what is cosine similarity, and what is Manhattan distance?
Yes, ma'am.
Everyone clear? Anyone having any issues, any problem?
Clear, ma'am.
Clear, right? Okay, fine. So now what we'll see how we can do, like practically we can do a clustering, right? So what are the steps that we need to do? Fine. First, we need to do a proper, we need to understand what is the goal. Like we need to define the goal. What is the goal of the problem? Then we need to collect the
Yes,
data.
ma'am.
Guys, is my voice coming late to you? Some of you are replying a bit later.
No, ma'am.
No, ma'am.
Okay. So it is like first we need to define the goal, then it is we need to collect the data, like we need to get the features, what actually matters, like we need to do the pre-processing stuff and all. So then we need to clean it, clean the data. Then we need to do the pre-processing. Cleaning the data means we need to see if there is missing values. We need to if there is any duplicate value. If there is any like difference, like we need to change with the types and what are like the basic data wrangling step that we need to do. That comes into the cleaning data part. Now we need to do the pre-processing. What comes in pre-processing? That is scaling. So we can do encoding and we can do feature engineering. Okay. So these are the steps that comes in pre-processing part. And eventually we need to, after this part is done, we need to choose the model or choose the algorithm. Okay, we need to choose the algorithm. Next, what we need to do, we need to we need to pick the parameters, like whatever be the parameters that we need to pick. Suppose you can think of k means. In k means, it is your from your choice, right? How, like what value you need to choose for k. So this is how you need to pick the parameters. Okay, so you need to pick the parameters, then you need to fit the model, and then you need to do the evaluation. After you are done with the evaluation, then you need to interpret whatever be the result. Like suppose in evaluation for this model, suppose one model you got accuracy of 90%, for another perspective, for another model you got the result as 91 or 92%. Then in the interpretation stage, what you do, you try and analyze which model works better, what is the criteria, based on that the model work better, or what is the criteria that has chosen taken into consideration, and for that the other model did not perform well. Like you need to do the interpretation. Okay, after interpretation, what you do, you need to save the model and deployment. Save model, like best performing model actually, and then is deployment. So it is clear what is trying and following in this case.
Yes, ma'am.
Okay, so now we'll just go ahead with k-means. So anyone understood like what actually is k-means algorithm? Tell. Most of you have implemented it, right? So tell me, what does k-means? Guys, no one? You already have implemented it in the
Ma'am, can
project
I?
that you have taken into consideration. Yeah, yeah, definitely.
Ma'am, yes.
Yeah,
Actually,
yeah.
it is a
Tell,
unsupervised
please.
K-means clustering is that we will group the similar kind of data points as a cluster based on a distance calculation, which can be calculated using the Euclidean distance, cosine similarity, or Manhattan distance. Uh, Based on the Euclidean distance and
Okay.
those points, the cluster value will be sorry based on that Euclidean distance, those number of clusters, and similar based on the number of clusters, the grouping will be done uh, between the data points.
Okay. Okay. Got it. Okay, Asani. Fine. So she has explained the stuff pretty well. So let's just do. We will not go into deep into that. We'll just go into a manual example, see how the things are. Because when we'll see the stuff in manual format, it becomes easier for us to understand and eventually go through. Fine. So let us just take. First, we'll just discuss K means. Okay, just a minute. What happened to the end? Fine. So what exactly is the idea of the algorithm? So let me just algorithm. So what actually is the idea? In a very simple format, she has told most of it. So I will just go ahead and pick each of it, and will directly move into an example for better understanding. Fine. So what we'll do first, what we'll take, we'll pick K, we'll pick the K value, like the whatever be the K value I will take into consideration. Then what we'll do, I will assign each point to the nearest center. Okay, assign each point. After that, we will be doing, we will recomputing the center as the average of the assigned point, because we need to do the averaging of the center, and we need to do repeat it. We need to repeat the step until we are getting a like stable format. So what we will be doing, we will choose K. We initialize the K centroid like randomly by some any of the form. We will be choosing the K centroid. will repeat the centroid, like we'll take into consideration and will repeat the centroid that doesn't, like based on that we will be moving for the same k value and we'll get the values done. And after that we'll assign each point for that very centroid or the k value. We will be taking like the key point, we will be assigning each point to that very nearest centroid. We'll calculate the distance basically. Okay, then we'll compute each of the centroid as the average of the assigned point. So understood what I told? So let's just go into deep into an example, take an example for better understanding. So example wise, what we can take? Example wise, let us take data points. So that would be x comma y, because we do try and follow this type of x1 x2 x1 y2 x, sorry, x1 y1 x2 y2 is this type of form we generally took in case of data points. So a, that what would be, suppose let me take it as 1 comma 1. B, what we can take, we can take it as 2 comma 3. C, we can take it as 4 comma 3. D, we can take as 5 comma 2, or we can take 4 also, not an issue. Okay, so we are done with the data points that has been there with us. Okay, now we need to choose the k value. So let me just take the k value as 2. Okay, now we are starting with the centroid. We need to, since we have taken two values of k, now from this from this value, from this data points, we need to take two centroids, centroid 1 and centroid 2. So C1, let me just take it as 1 comma 1, and we need to take centroid 2, let me just take it as 5 comma 4. Two extreme values we have taken, that is A and D. These two value we have taken. Now what we need to do, we need to assign point to nearest centroid. So we need to calculate the Euclidean distance. Okay. So what we will be doing for C1, we will be for point 1 comma 1, and for centroid C1 will be calculating the Euclidean distance. So I'm writing in short, that is UED, that is Euclidean distance, that is 1 minus 1 square. We need to do just a minute. 1 minus 1, then we need to just square it down, then we need to plus it, and then 1 minus 1. Now we need to square it down. And that whole thing will come as a square root. Okay. So this is actually the formula of Euclidean distance. So after we do it, it will be 0, right? Because 1 minus 1 is 0, squaring it will give 0. 1 minus 1 is 0, squaring it also will give 0. Now adding up will get 0, and square root of 0 is 0, right? So we are getting the result for A. Let me just write it for point A 1 comma 1 with C1 centroid, that we are getting as 0. So it is close to which one? 0 is obviously close to 1.1, because 1 comma 1 is the first, 2 comma 1 is second, C is like this. We are actually comparing between this and this, between the centroids, the distance between the centroid. So between these two centroids, 0 is close to C1, right? Close to C1. Understood what we are doing, guys?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay. Great. So
Yeah,
next,
ma'am.
what would be next step?
Got it,
And
ma'am.
what would be the next step? You tell.
We take the data point B.
Which data point? Which data
B.
point we will take? No. For A only we have considered C1, but for C2, from C2 we haven't calculated the distance, right? So we need to calculate the distance from the centroid 2 as well. Because K value we have taken 2 and we have got two centroids, taken two centroids. So from C1 we have taken the A11 from centroid C1, taken ED, right? So now we need to do it for C2. Now we need to do it for C2. Okay. So now we'll be doing 1 minus 5 and we'll be doing 1 minus 4 because the value is 4, 5 comma 4. So what we will be getting root of 1 minus 5, that is minus 4, that is 16 plus 9 and that is 25. Square rooting it, we will be getting 5. Right? So it is 5. Now what we'll be doing, we will be considering for B. Guys, can anyone take a snap of this value so that it becomes easier to get in through
Yes, ma'am.
and tell me when I'll just write it down? Yeah.
Yes, ma'am. Done.
Done? Okay, okay,
Yes.
fine. So for B2, we'll go for again the centroid C1. So what is the C1? That is 1 comma 1. So now for B, what is the B point?
2 comma 1, ma'am.
2 comma 1. Okay, fine. Yes. Okay, fine. So for that, we'll check accordingly. Similarly, we'll be doing. So the same thing we'll be doing. Now here we'll be doing, since the point is 2 comma 1, so 2 minus 1 and 1 minus 1. So what it is? So square rooting it, we get 2 minus 1, that is 1 square, and it is 0 square, and then we are getting the value as 1. Now for C2, C2 the point is 5 comma 4 or 4 comma 5. Which one it is?
5 comma
5
4,
comma 4?
ma'am.
Yeah, okay, fine. Great. So we'll just take a look, we'll do it. So now what we'll be doing? We'll be doing 2 comma 5. 2 comma 5 and 1 comma 4, right? So what we'll be getting? Minus 3. So square of minus 3 is 9. Here also minus 3 will be square root of 9 plus 9, that is 18. Square root of 18 is around, it is around 4.2 around. Okay. So for C1, C2, for point B, it is done. So for point C, we need to check what is the point C?
4 comma 3, ma'am.
4 comma 3. Fine. C1 is 1 comma 1. Now we need to take it for C. So similarly, we'll be doing. So it is 4 comma 1, 4 minus 1. Then it is 3 minus 1. So what it is square, 3 squared plus 2 squared, that is 9 plus 4, that is 13. 13 is around 3.6. Okay. Then C2, that is 5 comma 4. So we're doing this. We are doing this, so it will be 4 comma 5 my plus 3 comma 4, right? Three comma four. So what it is? So it is coming up minus one minus one. So 1 plus 1 2 square root of 2 4 1 4. So we are done with till for C. For D we need to do. D is 5 comma 4. So we'll do this. So it is for C1 it is 5 minus 1. 5 minus 1 and going down it is 4 minus 1. So what it is 4 square plus 3 square, that is 16, plus 9, that is 25, that is 5. Right? Next, similarly for D2 will be doing, so that would be definitely 0 because 5 minus 5 and 4 minus 4. So this is coming up to 0. So what it is, so D, what we are seeing, D is closer to, okay. So now we need to check for the clusters. Sorry. D is closer to C2. Right. Now what we are doing, we are moving ahead. We need to check. So suppose which all are into the like after we need to assign for the clusters. So since this one is close to 0, we have got it for C1, and for this one we are getting it around this like 1 and 2. So since we are getting it at 1, so A and B will consider under centroid 1, that is cluster 1, and C will be cluster 2. Okay, so C1 will be compared with A comma B, and C2 will be compared for C comma D. Okay, so now we need to repeat the step again. Now we need to, what we need to do? We need to compute the centroid, like we need to assign the, we need to like average assigning points. So now we need to get a new C1. Okay, so now see new C1, that is average of point A comma 1, like we need to do average of 1 comma 1 since the point A is 1 comma 1. And what is point B? Point B is 2 comma 1. 2 comma 1. Right? Now we need to like again do it. So averaging for x coordinate, what will be 1 plus 2? That is 3 by 2. So for we'll just do the average. That is 1 plus 2. Sorry, 1 plus 2 divided by 2. That is 3 by 2. 3 by 2 we are getting 1.5. Next for y, what we will be doing? So for y, we will be doing 1 plus 1, that is 2 by 2, that is 1. 2 by 2, that is 1. Just a moment. 1. So new C1, like new centroid that we have taken into consideration, that is 1.5 comma 1. Similarly for C2, C2 was 5 comma 4. Now we need to do the average. Like C, what is point C? Give me the point for C. Guys, are
4,
there?
3, ma'am.
No one is there? What happened?
4,
Ma'am.
3, ma'am.
Yeah, ma'am. There.
See, this one. This one I am asking.
4, comma
4,
3. Yeah.
3. C, it is like this. And D, what it is? 5, 4. So what we are doing? Doing the average. That is 4 plus 5 divided by 2. That is 9 by 2. That is 4.5. And Y, it is 3 plus 4. That is 7. 7 by 2. That is 3.5. Sorry. 7 by 2. That is 3.5. 3.5. So new C2, that is 4 comma, sorry, 4.5 comma 3.5. Understood,
Yes, ma'am.
guys?
Yes, ma'am.
Yes, ma'am.
Am I not audible? What happened?
Yeah, ma'am. You're audible. We said yes.
Hello?
Hello.
Hello.
Yes, ma'am, you
Yeah,
are audible.
ma'am.
Yeah, ma'am. You're audible.
Hello?
Only
No, why no one
replying
is
to
speaking?
you.
Ma'am, we are saying.
Ma'am, we are
Okay,
speaking,
okay,
ma'am.
sorry,
Ma'am,
sorry.
we are saying.
Okay, okay, got it. There was no sound, like the sound has muted somehow. So I was unable to hear any one of you.
No,
Okay,
ma'am.
ma'am. No,
We were
okay,
saying
ma'am. No
yes.
matter.
I got it. You people were saying, but for my case, the sound of my laptop has gone down. Like it was got muted. That's why I was unable to hear from you. Okay.
Okay, ma'am.
So
Okay, ma'am.
clear what I told till now. Everyone understood.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes,
So
ma'am. Yes, ma'am.
Yes, ma'am.
okay, great. So this will continue. This process that I told you, that I showed you, this will continue till the point when we'll be not like when this centroid values, we are getting new centroid C1, new centroid C2, right? So there would be a point this value will not change. It will for the this iteration it is 5.1 comma 1 and C2 is 4.5 comma 3.5. So for this next iteration also, this value will be same. Till that point, this iteration will go. Okay, understood, everyone?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, okay, great. So hopefully everything you understood in today's session. So we'll just
Yes, ma'am.
stop here today. Okay, so we'll just stop here today. So anyone of you having any questions relevant to it, guys?
No,
No, ma'am.
ma'am.
We understood.
Everything you understood, right? So tomorrow we'll just go ahead and we'll do it in collab and try to understand from it like how we can do a k-means clustering step by step, right? So we'll just learn how we can train a model, k-means model, how we can go ahead with the data and train using k-means algorithm, and based on that, how we can go ahead. Fine. And we'll also
Yes,
see
ma'am.
about other models, other unsupervised models. Fine.
Okay, ma'am.
Okay. So any questions, any doubt, anyone relevant to anything you can ask?
Ma'am, can you please repeat until when this iteration goes on?
Okay, fine. So okay. So you can see this point, right? For K, we have taken two, C1, C2, we have taken the points, right? So then, after we have done or performed all of this operation, we have got the value, new value of C1 as this. So the value of C1 has updated and the value of C2 has also updated. That is centroid 1 has also updated, centroid 2 is also updated. So this iteration has happened. Suppose 2, 3 points it has gone. Then there would be a point when this value of new C1, C2, sorry, suppose C1, C2, take it as C1, C2. C1 is like this and C1 is C2 is like this. In the next iteration, when I am getting the value of new C1, this will be same as C1 and the new C2 value will be same as this C2 value. Got it? So this
Yes,
centroid
ma'am.
value will not change.
Okay, ma'am. Got
So
it.
till that point, this iteration will move. So any
Got it,
other
ma'am.
question,
Thank you.
guys? Okay, great. So any other question, guys? Anyone?
No, ma'am.
Okay, great. So we'll just stop here today. We'll meet tomorrow and accordingly we'll just move ahead. Fine?
Okay,
Mom,
ma'am.
actually, I had just one question.
Yeah, Del.
Means, how can we know how much progress we have done into the 3 weeks?
Yeah.
Means overall,
Sorry,
we have submitted our projects and all everything, but we are just doing it. But how can we know that how much performance we had done well, how much what we are lacking, and all the stuffs we are just behind?
okay, I understood. So for the persons who have actually given the presentation in the session, for them from my end, I have given the scorecard that the person can improve, right? So eventually, for some people, I have also told them to improve on the presentation. So this much is fine, but for the final evaluation, you need to wait until the last week. In the last week session only, like after the last week, the major project, when you will be given or submitting, after that only you will be getting the other like in what project, what how much marks have been given to you and what is the evaluation stuff that has been given to you. You will get the report. Okay, so as of now, there is no such mechanism that for each week you'll be given with any of the evaluation perspective. So from my end, I can just give you suggestions or points of improvement. Since I am showing your projects or I am just showing your presentation based on that. Fine.
Yeah, ma'am, got it. Thank you.
So any other question? Anyone?
Ma'am,
Yeah.
I have submitted my project on the given link. It was week one
Okay.
project and I have joined late. So, ma'am,
Okay.
is it
Week
being
one you have
evaluated?
submitted.
Yes, ma'am.
Sorry,
Is it being
I didn't
evaluated
get
by
you.
evaluation? I'm asking for
Yeah, I guess
evaluation.
since you when you have joined,
Ma'am,
I got it. I am asking when you have joined.
last Friday.
Okay, so I guess that will get evaluated. Don't worry.
Okay.
Fine.
Okay,
So
ma'am.
similarly, submit week two, week three project as well. Okay.
Okay, ma'am. I'll submit.
Yeah. Okay, fine. Bye, guys. Then we'll just
Ma'am,
wrap up our session today. Yeah.
ma'am, can you show me once syllabus?
Sorry.
Ma'am, can you show me a syllabus once? Week one, week two, and week three.
Okay. So I guess now I'm not having that. Just a moment. Let me check. Yeah. So this is for week four, and week five will go ahead with neural network, and for the 6th week we'll go ahead with the deployment and the project, final project.
And ma'am,
Okay.
one, two, three also. One, two, three also. Yes.
One, the major part of Python, then the data visualization like the EDA and the supervised learning.
Okay.
Okay.
Okay, thank you, ma'am. Thank you so much.
Okay, fine. So fine, we'll just wrap up now. Okay. Bye, guys.
Bye, ma'am.
Bye bye.
Thank you, ma'am.
Bye, ma'am.
Thank you, ma'am. Bye
Bye,
bye.
ma'am. Thank you.
Thank you. Bye bye. Bye. Bye bye.
Thank you, ma'am.
Thank you.